So today we're going to do lesson 8 instead of lesson 7 because I think it's easier. Really, everything is going to be equations, not inequalities, and you already know how to solve systems of equations. So 5 times the smaller of two numbers is subtracted from twice the larger. So I'm going to let x equal the smaller number and y equal the larger number. And we just write equations like we always used to. So 5 times the smaller is subtracted from, so I'm subtracting that from something, from twice the larger, and the result is 16. And if the larger, that's my y, is increased by 3 times the smaller, the result is 63. So that's the setup for the equation. Looks like we can solve it by elimination. You can multiply maybe the bottom equation by a -2, and you would continue to solve this and get an answer. I'm going to leave the rest for you to do in class or at home, depending on time. Number two is something that has like the two totals, similar to like our, when was it? I don't know. Like our last unit, we did something like this. At a quick lunch counter, 3 pretzels and 1 cup of soda cost $2.75. So I'm thinking it has to add up to $2.75. And then 2 pretzels and 1 cup of soda cost $2, so it adds up to $2. So I just need some let statements so I can write the rest of the equation. I'm going to let P equal, I have to find the cost of a pretzel and the cost of soda. So P is the cost of a pretzel. And C, or how about S, is the cost of soda. So now I go back, 3 pretzels and 1 cup of soda costs $2.75, and 2 pretzels and 1 cup of soda costs $2. Again, this can be done by elimination. Maybe you want to multiply the bottom equation by -1, and on your own time, either later in the period or at home, you will solve this. Number 3. Linda spent $3.60 for stamps. Well, that's definitely a total. $3.60 is a total. Some were 30-cent stamps and the rest were 20-cent stamps. Those are my 2 types of things. I guess those are my 2 variables. The number of 20-cent stamps was 2 less than the number of 30-cent stamps. How many stamps of each kind? Yeah, so why don't we let X equal the number of 30-cent stamps. So Y is the number of 20-cent stamps. Now I'm going to go back and write some equations. I need something for this total. This total is money, so I know I can use money on the left side. So X is for 30-cent stamps, so why don't I use 30 cents times X plus 20 cents times Y. And that's how we could get our $3.60. The other one is a number of things. The number of 20-cent stamps, so that's Y, was, which is like an is, 2 less than the number of 30-cent stamps. 2 less than the number of 30-cent stamps. So that would be X minus 2. Y equals X minus 2. This one looks like it's set up for substitution. Take this X minus 2 and replace it in for Y, and then solve the equation. Let's go look at number 4. Number 4, I think this is our first time maybe seeing something with percents. We know that percents can be changed to decimals. So 4% is really the same thing as 0.04. You have to move the decimal 2 places to the left. And 7% is like 0.07. And then whenever you want to find a percent of a number, you can always multiply by the decimal. So I have two numbers. I have a larger number and a smaller number. So how about we let x equal the smaller number? Every time I do my let statements, I get to choose what variable I want to use and what I want my variable to stand for. So if on your own you decided to maybe let x be the larger number, you wouldn't be wrong. We're just going to do this together right now, so therefore let's all agree that x is the smaller number and y is the larger number. And now we have to write the equations. This first sentence, the sum of two numbers is 900. Well, my two numbers are my x and y, so I guess x plus y equals 900. And then the other one is percent. So 4% of the larger. 4% of the larger. The larger is my y, so I need the 0.04 with the y. And I'm already anticipating that it's going to be elimination, so I'm lining up my y's. 4% of the larger is added to 7% of the smaller. And since this is addition, I don't really have to worry about the order that I am writing this, because addition is commutative, and I just want my x's and y's lined up to maybe do elimination. And the sum of that is 48. Now this one, honestly, you can do by elimination if you multiply the top by maybe negative 0.07, or maybe you want to take the top and maybe subtract x from both sides and y by itself, and you can do substitution. But you get to choose, you're going to solve that on your own. Number 5, I think I'm going to do full out with you. Number 5 is a question that we've seen on a Regents exam. So, and school, well, right there, that's typo. A school spends $3 per box of pencils and $5 per box of markers. I'm already thinking that 3 has to go with pencils, 5 has to go with markers, but I'm going to keep on reading. Pat noticed that the school spent $250. This is like a total. So I'm going to put that at the end of an equation. He spent $250 on pencils and markers on Wednesday. Write an equation to represent the possible number of boxes of pencils and possible number of boxes of markers. I'm going to use P for pencils and M for markers. So I'm going to let P equal, and remember we're trying to find the number of boxes of pencils. P equals number of pencils, while M equals number of markers. And really it's the number of boxes of markers, the number of boxes of pencils, but it's all right to just write this. $3 for the boxes of pencils, $5 for the boxes of markers, and a total of $250. So there's our equation. Now, since we only have one equation, really P and M can be multiple things. So when we look at this next part, Pat said that there might have been 40 boxes of pencils and 30 boxes of markers. Are Pat's numbers correct? Well, why don't I plug in a 40 for P and a 30 for M and see if it really turns out to be $250. So 3 times 40 plus 5 times 30, does it equal 250? So 120 plus 150 adds up to be 270, and that does not equal 250. So we answer the question, are Pat's numbers possible? No, Pat's numbers are not possible. And I just want to point out something. At the end here, it says use your equation to justify your answer. I did use my equation to justify. Justification really is some math work. I don't have to use words to explain. I justify. Now the next part Later, Pat found a record showing that there were a total of 70 boxes of pencils and markers. This is nice that there's a second total. Now I'm going to wind up having a system, and when you have a system, you can solve if there are two variables. If there's just one equation with two variables, really I can't solve and get a number, but now I have another total. It's a total number of boxes of pencils and markers put together. Remember, we let P be our boxes of pencils and M be our boxes of markers, so P plus M must be 70. But I already knew that on Wednesday they spent $250. So I'm going to use this equation from up above, this 3P plus 5M equals 250. Now I have a system that I can solve. Which way would you like to solve it? Do you like elimination? Do you like substitution? Either way would be okay. I'm going to do elimination. I'll multiply the top. What am I going to multiply by? They're only asking me right here how many boxes of pencils were bought for the school on Wednesday. They're not even asking about the markers. So I'm actually going to multiply by a -5 to make my markers be eliminated, and I'm solving for P, which is pencils, and then I have my answer. So the top equation, I'm just going to rewrite it over here. It will be a -5P minus 5M equals -350. The bottom equation I keep as is. I can add these together. And the markers are eliminated at -2P equals -100. Divide both sides by -2, and P equals 50. When they're asking you a question in words, you should always answer in words. So how many boxes of pencils were bought for the school on Wednesday? 50 boxes of pencils. I think the rest you're probably going to do on your own. Actually, number 7. It's kind of a trick in number 7, so let's take a look at number 7. I'll help you set it up, and then you'll be on your own. So gardener is planting 2 types of trees. Oh, something else that I really like about 7, and I'm glad I'm doing it, is I'm noticing that these equations are actually in y equals mx plus b form. So many of the other equations were just like total kinds of questions. So we can see that there's a tree, type A. It's 3 feet tall, and it grows at a rate of 15 inches per year. So 15 inches per year, a rate of 15 inches per year, that's like a slope, right? It's a rate of change. And it started at 3 feet tall. That's like the initial height. And initial height is like a y-intercept. At time 0, at the very beginning, we started calculating or keeping track of how it's growing. Started at 3 feet, and it grew 15 inches per year. And then type B started at 4 feet, and it grew 10 inches per year. So a common mistake for this is people want to write for type A, and don't write this, I'm going to fix it. Type A, a lot of people want to write y equals 15x plus 3. But oh no, this is not a plus 3. This says feet, and this says inches. I can't have 2 different units in the same equation. So 3 feet is the same thing as 36 inches. So really, I'm using y equals 15x plus 36 for type A. And now you should be able to do type B because it's the same concept. I'll change the 4 feet to 48 inches, and we'll use y equals 10x plus 48. And they're asking to do it algebraically, to determine exactly how many years it will take for these trees to be the same height. To be the same really means to be equal to each other. So why not take this and plug it into the other, right? Y's are the heights. We want to know when will the heights be the same? Maybe we should write down those let statements. I let y equal the height, and I let x equal the number of years. So 15x plus 36 equals 10x plus 48. When you solve for x, you'll know the number of years. I'll let you know it is a decimal, so don't panic when you get a decimal. And you're going to complete the rest for homework. So whatever time is left in the period, you can work with your partner and do the rest for homework.